So, picking up where we left off yesterday, these transformations, linear, quadratic, absolute value. We have these here. We said vertical translation, our up, down, is our k. Whatever the value of k or number that's going in the place of k will tell us how far it moves it up or down. H tells us how far it moves it to the left or to the right. And again, our horizontal translation is kind of the opposite of what we think. Because if we see inside parentheses our absolute value x plus 3, it's going to be moving 3 units to the left. X minus 3 is going to be to the right. Left and right is kind of the opposite of what we think. If we have a negative in the A spot, if the number or sign of A is negative, we have a reflection across the x-axis, specifically if it's a negative. And the most recent thing, kind of where we stopped yesterday, we didn't get to do any examples of it yet, is vertical stretch and vertical shrink. And vertical stretch and shrink is really based off A. If A is greater than 1, it's a vertical stretch. If the value of A is between 0 and 1, it's a vertical shrink. And when we talk about this vertical stretch and shrink, what we're saying is that the y values, it's going to increase faster. It's going to go up quicker. And for the most part, that's going to make it look skinnier, especially for our absolute values and our quadratics. The sides of the parabola, the sides of the absolute value are going to get closer together because the y values are increasing at a faster rate. Another transform it other than 1, when the factor is greater than 1, the transformation is vertical stretch. When the factor is greater than 0 but less than 1, between 0 and 1, it's a vertical shrink. So we look at this first one here. G of x equals 2 times the absolute value of x. Well, the parent function that it goes with is absolute value. And absolute value kind of gives itself away because we have to say, as we're reading it, we kind of have to say absolute value to be able to read it. Now we're going to compare this to the general form. A times the absolute value of x minus h plus k. Do we have a value for k, a number in where the spot where k is at? Well, no, we have nothing being added to the end of the absolute value, which tells us it's not moving it up or down. Is there a value for h? Well, no, so that means it's not moving left or right. But we do have a value for a, yes? And that value is 2. So is 2 between 0 and 1 or bigger than 1? Bigger than 1, yes? So that means it has to be a vertical what? Vertical stretch. And when we talk about this one here, we'll say that it's a vertical stretch of 2. Because we have to specify how much we're stretching, how faster or how much quicker the y values are increasing by. What factor are we stretching it by? We're stretching it by a factor of 2. So everything's increasing by a factor of 2. Now, is that a value negative? Is that 2 negative? No, so there's not a reflection across the x-axis. Because when we have a value there for a, if it's negative, it tells us it's a reflection. The number itself tells us if there's a stretch or shrink. Also, for stretch and shrink, that number has to be different than 1. 1 tells us nothing. It's not changing anything. Clear both of these out. Now the absolute value of x is this here. We said it's the absolute value function. We said the new function 2 times it. So it's increasing faster. As we can see, the sides of that absolute value are getting steeper. They're going up quicker. They're increasing faster. So it is a vertical stretch. We're stretching it vertically. And we get this here. Does that make sense? Now, it didn't ask for this or it didn't have it. We could say 1/2 times the absolute value of x. So this should be a vertical shrink. That means the side should open wider by a factor of 1/2. We're taking all the values of y and cutting them in half. So they're increasing slower along the y-axis. It does make it wider, but it's a vertical shrink. We got to understand this here. Let's look at b. What's b's parent function? It is a quadratic. And we know it's a quadratic because of the x squared. That square, the power of 2, is a quadratic. Now again, I'm going to write the general form. If that helps, write it. If it doesn't, you don't have to. Again, do we have a value for h and k? No. Because for h, we will need parentheses written. X minus a number, x plus a number, inside parentheses being squared. The only thing we do have a value for is a, yes? And the value of a is 1/2. Greater than 1 or between 0 and 1? It's between 0 and 1, so it'll be a vertical shrink of 1/2. And that's it. Questions on A or B? Let's look at number 5. G of x equals 3x. This would be a part of which family? Linear. Because we're looking at the x. Because the x is to the first power, it is a linear function. And realistically, we call this the 3x is a linear term. Because the x is to the first power is linear. It's not there, but if we had plus 3, 3 is our constant term. Constant function, constant term. No h, no k, but the value of a is 3. And because it is in the a spot, it's telling us that we have a vertical what? Stretch of 3. Yep, that's it. 6. What's the family? Quadratic. Do we know what the transformation is going to be? It will indeed be a vertical stretch. But the question is, how can it be a vertical stretch if I have a fraction? It's 3 over 2, which is it's bigger than 1, yes? Doesn't matter that it's a fraction, because how we determine if it's vertical stretch or vertical shrink wasn't, it's a vertical stretch if we have a whole number, and it's vertical shrink if we have a fraction. It's a vertical stretch if the value of a is greater than 1. Period. Doesn't matter what the number is. If it is greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. If the sign of that number is negative, it doesn't matter stretch or shrink. Because if that value of a is negative, it is a reflection. The negative tells us it's a reflection. The number itself tells us if there's a stretch or shrink. Make sense? And it's very easy to get those two flipped. to think that because it's negative, it's a shrink. No. If it's between 0 and 1, it's a shrink. Last one here, 7. It would be absolute value. And the transformation would be vertical shrink of That's it for this part here. Questions? We're going to do two more problems. So looking at this graph here, so identify the family to which the function belongs and compare the graph of f to the graph of its parent. Describe the transformation. So what's the parent function? Which one had a V shape? Absolute value. Absolute value. A, absolute value, x minus h plus k. Do we have a value for h for this here? No, so there's no left and right. Do we have a value for k? It is 1. Are we going to move up or down? Because the 1 is positive or negative. So it would be, because remember, up and down is exactly like it looks, exactly like we see it. Because it's not inside parentheses or absolute value, so it's up 1, yes? All right, so we're done with that one, yes? So you're going to be like, no. Do we have a value for A? Yeah, we do. This is the first one we've done, where we haven't just had one transformation. What is A? 2, is it positive or negative? Positive. Since it's positive, is there a reflection across the x-axis? No. Only if it was negative. But it does tell us that we have either a vertical stretch or vertical shrink. I'll give you this hint here, vertical S. It's going to be stretch. Because 2 is bigger than 1. Vertical stretch of 2. And that's it. Because there's nothing saying that we have to have exactly one transformation or two. We can have multiple transformations being applied to a function. So we look at this one here. We have 1/4 times the quantity x minus 3 squared. The parent function would be a quadratic. Do we have a value for k? No. Do we have a value for h? Yes, and the value for h is? So it's 3. Now the sign, positive or negative, we need to figure out if we're going left or right. And we'd be going to the right. Yes, because it's opposite of what we think. It looks negative, but it's actually positive. So we would be going to the right. Right 3. Do we have a value for a? Is it negative? No, so there is no reflection, but we do have a vertical stretch or shrink. And it'd be a vertical shrink of 1/4. That's it. That's all I have to say, because there is no k, there is no negative for reflection. That's all we got. Questions on this here? You ready for the next one? So describe the transformation and its parent function. Well, the parent function is absolute value. Do we have a value for k? So it tells us it's moving where? Down. Yes, down how far? 3. Now, we do have value for h, which would be our left and right. And the value, so we have 5 left or right? Left. As it would indeed be down 3, left 5. Anything else? We have a negative for a, yes, which would be a reflection across the x-axis. That's it. Questions on any of this here? That's it. So homework problems 3 through 5. So problems 3 through 5, those there, name the parent function, describe the transformation. That's all it's asking. 9 through 15, odd. And 9 through 15, you're doing only the odd problems on that one. Describe, or essentially name the parent function, describe the transformation. That's it. 19 through 25, odd. Only the odd problems on 19 through 25. Again, same thing. Name the parent function, describe the transformation. And then 27, 28, 31. Name the parent function, describe the transformation. And that's it.